Imagine standing on a cliff edge, brilliant white buildings gleaming in the Mediterranean sun behind you. The blue waters of the Aegean stretch before you in a perfect crescent. But this isn't just any bay. You're actually gazing into one of the world's largest volcanic calderas. This is Santorini, the picture-perfect Greek island paradise that Instagram dreams are made of. But what tourists marvel at today was born from apocalyptic destruction. 3,600 years ago, one of history's most catastrophic eruptions tore through the heart of this island, shattering it into fragments and ripping the island into the vertically cliffed amphitheater it is today. The advanced civilization that once thrived here vanished in hours, buried under ash and tsunami waves. Is this what Plato immortalized in his famous tale of Atlantis, the advanced kingdom swallowed by the sea in a single day and night? For thousands of years, Santorini has slumbered, but in recent weeks, something has changed. Thousands of earthquakes have suddenly begun rattling the island's foundations, 20,000 tremors in less than a month. This week, we're going off the radar with a geologist to peel back the postcard veneer of this island paradise and face an unsettling question. Is paradise about to be lost once more? We'll explore not just Santorini's rumbling depths, but the cutting-edge science of volcanic systems around the globe, from the Mediterranean to Yellowstone and beyond, and what they mean for communities living in their shadows. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do.
This new year, why not let Audible expand your life by listening? Explore over 1 million audiobooks, podcasts, and exclusive Audible originals that'll inspire and motivate you. Tap into your well-being with advice and insight from leading professionals and experts on better health, relationships, career, finance, investing, and more. Maybe you want to kick a bad habit or start a good one. If you're interested in learning how to master your emotions and hearing scientifically backed advice for using your emotions as a tool, may I suggest Shift by psychologist and bestseller author Dr. Ethan Kross? Trust me, listening on Audible can help you reach the goals you set for yourself. Start listening today when you sign up for a free 30-day trial at audible.com/Wondery. That's audible.com/Wondery.
The Greek islands evoke idyllic images of whitewashed homes dotted with blue-domed roofs, of sun-baked hillsides overlooking placid waters off the coast, and fishing villages from antiquity that are almost as old as civilization itself. But beneath the plaster and tile, there's an archaic secret that has recently begun whispering its legends. Thousands of years ago, ancient Greeks might have thought it was the angry rumblings of the gods themselves. It might have felt like Zeus's lightning bolts were being hurtled down from Mount Olympus and striking the ground, or like Poseidon's trident was plunging into the underwater depths of the earth to swallow up entire civilizations in a dramatic show of force. Today we can track those tremors to seismic activity, but the stakes are just as high as they were for the ancient Greeks. The island of Santorini juts out of the Aegean Sea in a dramatic fashion. It was formed by volcanic activity as layer after layer of molten lava folded over itself and hardened into rock. Around 1620 BCE, Santorini volcano experienced a major eruption. It had a volcanic explosivity index, or VEI, of 7 on a scale from 0 to 8. The eruption caused a substantial part of the original Santorini island to be destroyed or plunged into the sea. Some historians have even speculated that the submerged Santorini civilization was the real-life inspiration for the lost city of Atlantis. The present-day island of Santorini, Greece, sits in a volcanic caldera, which is what gives Santorini its staggering cliffs along the west coast. The 1620 BCE was the last major eruption in Santorini, but recently, the region has been rocked by substantial rumblings. The island experienced hundreds of small earthquakes in the span of just 3 days. In total, they recorded over 20,000 earthquakes between January 26th and February 22nd. Magnitudes that were typically between 1 and 4.9, with the epicenters generally centered underneath the ocean. But seismologists fear that the quakes could increase in intensity. If they shifted their epicenters on land, they could potentially cause more damage. And even if the epicenters remain under the seabed, some fear that the underwater seismic activity could potentially trigger a tsunami that would endanger coastal areas. Today I'm talking with Shawn Willsey, a geologist and geology professor whose work covers rock formation, fossilization, and earthquakes. We'll cover the real risks in Santorini and what's happening below the surface to cause these quakes. Shawn, thanks so much for coming on today. I am not an expert in volcanoes by any means. My expertise is the atmosphere. So I'm really glad to learn from you today and get a little bit of background information, not only on volcanoes, but one in particular that's kind of interesting and a lot of folklore, I feel like, around it. So we're going to talk about Santorini in Greece and what's been going on there. But can you tell me, first of all, who you are and what you do?
Yeah, my name's Shawn Willsey, and I am a college geology professor at the College of Southern Idaho. My background is mainly in structural geology, so kind of how faults behave, but also been doing quite a bit with volcanology over the past 15 to 20 years. I lead field trips to different places, written a few books. I dabble in the geology that interests me. That's probably a good way to sum it up.
And it doesn't just interest you, it interests the general public. I feel like people are really into learning about volcanoes. It's kind of like tornadoes and hurricanes where they really pack a punch and they're kind of sexy in the news. So people want to learn more about them. Let's go back and talk about this one particular volcano that's getting some attention right now. And it's way out. It's in Greece, in the Aegean Sea, correct? We've been talking about Santorini. Can you give me a little history on Santorini? Because I think this is the island people think of when they think of Greece, right? Like vacation photos, white buildings, beautiful photos, cliffside houses. So how did Santorini form, though?
Yeah, so it's one of the most visited places in Greece and the Greek Isles for sure. Just very picturesque, as you said. And I think a lot of its sort of scenic and aesthetic beauty is because of the volcanic history and what's gone on there. And so Santorini, along with a few other islands and locations in that part of the Aegean Sea, are part of what we call a subduction zone. So it's a little messy in the Mediterranean in terms of all these little tiny micro plates running into each other or pulling apart from each other. But there's a plate that's moving northward underneath the Aegean Sea plate, so underneath those Greek Isles. And as it does so, that process of one plate going underneath another generates magmas. And so that's the source of the magmas, is what we call a subduction zone, where one plate is pushed beneath another.
Okay, so there used to be a whole city there, and then volcano, 3,000 years ago, and now it's what we see today, right? Santorini. But I looked in it as recent as like the 1700s. There's been some movement here, right?
Yeah, so Santorini's famous collapse you kind of mentioned too, which was historic, was a what we call a caldera forming eruption. So basically the volcanic edifice, that island, and if you look at it on a map, Santorini is kind of this circular shape. There's like a central bay, and like you said, it's ringed by these steep cliffs where the whitewashed houses are kind of perched precariously upon. And that's because the center of the volcano, it had such a huge eruption that it collapsed in on itself. It evacuated so much of its magma chamber, propelling lava and ash to the surface, that it actually collapsed in on itself and formed what we call a caldera. So calderas are some of the most violent and destructive of all eruptions. They usually don't happen very often, fortuitously, but that particular one unfortunately struck that civilization in Greece thousands of years ago and changed dramatically the topography and the shape of the island. It also generated a large tsunami that propagated out throughout the whole Mediterranean region.
Okay, so now there's lots of buildings there, and in recent weeks, there's been a lot of earthquake activity, right?
Yeah, about a month or so, we've had a pickup in earthquake activity. It's what people are calling a seismic swarm, which is as good a name as anything for it. And what's interesting is it's different than the typical earthquake behavior we tend to see. We typically see what we call a main shock aftershock sequence, where the stress is building up in the earth across some fault. Finally, that stress reaches a level that the fault moves, the rocks break, the earthquake is generated of whatever magnitude. And then in the hours and days and weeks afterwards, we see aftershocks, right? So let's say there's a big, magnitude 7 earthquake somewhere in Greece or anywhere. There's the big event, the main event. And then we see over time aftershocks coming in that are smaller, but they tend to dissipate over time. They get less frequent and smaller in magnitude over time. The recent event in the Aegean Sea near Santorini has been very different. Instead of a main shock aftershock sequence, what we've been seeing is sustained earthquakes of a given magnitude, generally 4 to magnitude 5, low magnitude 5, that have been happening over about a 2-week period, along with many smaller earthquakes as well. So because these earthquakes are of a size or magnitude that people feel them, and they can be locally destructive, that's why they've had such a panic in the area with, shutting down schools, people evacuating on their own and maybe staying away from these tourist places that are normally visited. Is this seismic sequence has been sustaining kind of a consistent level of energy release for a good two plus weeks or so in that area.
So what does that mean?
We're not sure. So it's real perplexing to scientists. We've seen things like this before, but like I said, the tectonic setting is really complicated. It doesn't seem to be as simple as one singular fault that has an earthquake and then releases energy, like the main shock aftershock sequence. There's a series of faults in there. Even though this part of the Aegean Sea is what we call a subduction zone, where two plates are colliding and one sliding beneath each other, what's actually happening is that plate that's being shoved underneath is actually starting to peel back a little bit. It's actually starting to roll back. And so what it sets up at the surface above it is extension. So all the faults and all the earthquakes we're seeing, for the most part, in this area are what we call extensional faults. They're caused by rocks being stretched rather than rocks being squished. Again, what's so interesting is that you have lots of faults in the area. There's also volcanoes in the area, like Santorini. And they're all happening kind of in a similar area. Now, none of the earthquakes are happening, for the most part. This big seismic swarm's not happening right underneath Santorini or any of the other volcanoes we know about. But there is a relationship between the faults, potentially, and the movement of magma. And so the earthquakes are clear data. We can see those. We can see when the earthquakes are coming in, how big they are, their relationship to other quakes and known faults. That's kind of the clear part of the science. What's a little murkier is the uplift data. So when we have volcanoes and volcanoes that are going to erupt, we often see earthquakes. That's one of the signals. But we also see ground deformation. The ground is actually moving typically upwards because magma is moving closer to the surface. It's causing the ground to bulge and deform above it. We're not seeing a clear pattern of that, so to speak. We are seeing some areas of uplift, but those are also places where you'd expect to see uplift if you have faults moving up and down. So while the earthquakes are happening, and that's clear data, there's no clear signs for the most part that magma is going to erupt. What we can say is there's possibly some signs that magma is moving in the subsurface. So it's this chicken and the egg problem a little bit with faults and magma movement. Does the magma moving through the ground cause the faults to have earthquakes, or does the faults with their earthquakes create space for the magma to move? And that's kind of a tricky mess that geologists bicker about and debate. And that's the good part of science is, we can have competing models, and ultimately we end up hopefully coming to some consensus. And I think right now, to be honest, we're at a point where it's just too early. It's still fresh. The data's still coming in. The data's still being analyzed, and we don't have a clear indicator of what's going on. It doesn't look for now like Santorini is going to erupt, that we're going to have some cataclysmic volcanic eruption. And so it's been a little bit unfortunate that some headlines have run with that sort of sensational kind of take on things.
Yeah, well, it's definitely a better story.
Sure.
Okay, so besides the fact that we're not looking at something major happening or something down the road happening, what about some of the kind of immediate impacts? Like I'm thinking of these cliffside houses and landslides, and then also the ocean. Have there been any tsunami issues?
Yeah, great question. So the earthquakes have been large enough, and those slopes around Santorini are definitely steep enough. There can be landslides and slope failures. I haven't seen any of those in the news, but I wouldn't be surprised if has been some minor rock fall or some small slides, something like that. So that's definitely a concern with magnitudes that we're seeing in the 4 to 5 range, especially on those really steep slopes. The tsunami threat's not really something to worry about at this point based on what we're seeing, because to generate a tsunami with an earthquake, you need 3 things. You need an earthquake below water. We've got that. All these earthquakes are happening below the Mediterranean or the Aegean Sea. You need, secondly, an earthquake of a certain size. So you need earthquakes typically in the 6.5 and above range, because that's an earthquake big enough to actually break the seafloor. So it's actually has enough energy that it's offsetting the seafloor. These quakes have been up to 5.3, so they're just not energetic enough to create that. And then the third thing you need is an earthquake along a fault where the movement is up and down. Some earthquakes occur sideways, like the San Andreas occurs horizontally, so the movement is horizontal. Those typically don't produce tsunami because they're not displacing the ocean up and down. So we've got 2 of the 3. We've got earthquakes moving up and down, earthquakes along faults that are moving up and down. We're in the ocean, but the magnitudes aren't big enough. So for now, with the level of seismic data that we're seeing, there's just not big enough to produce a tsunami. So that threat, I wouldn't say is zero, of course. We're still in a very tectonically rich or active area. But given this seismic swarm over the last month or so, a tsunami is not likely.
Okay, so how do you predict a volcano? How do you predict not just like a small one or one that's kind of actively happening, but not doing much damage, but something like what happened in Santorini or, Mount Vesuvius? How do you predict an event that big?
First of all, volcanoes can't be predicted in the classical sense. We're never going to get to the point where we know, exactly at this day on this time, there's going to be an eruption of this magnitude. That's really what a prediction is. But we can forecast them just like you do with the weather. You look at the data, you look at the models, and you have a probability, right? Just like we say there's a 70% chance of rain tomorrow based on this cold front coming through. We can do similar things with volcanoes, but the first thing we have to do is look at their history. So we have to really understand the volcano and what it's done in the past. That comes from looking at the deposits, looking at the historic eruptions, the prehistoric eruptions, through analyzing all the available data. How thick are the ash deposits? How extensive are the lava flows? What has it done in the past? And then we combine that knowledge with monitoring. So we use instrumentation to look and see what the earthquake is doing right now and over periods of time. So that would include earthquakes. It would include ground deformation. So basically the ground moving up and down, which we can use GPS for, or there's other things called tilt meters. There's even satellite, the INSAR data that we can use. And then maybe something like gas emissions. Volcanically active regions will emit gas, and you can look at the concentrations and the measurements of the gases. So we combine all that information, and that helps us make a forecast, just like a weather forecaster takes not just the atmospheric, the temperature, the humidity, you look at everything, right? And then you put that in to maybe a computer or model, or you synthesize that data to figure out what might take place and look at the probabilities.
So there's been a lot of recent work done in weather when it comes to use of AI for computer modeling and improving forecasts. Has there been any AI use in the world of volcano prediction?
There probably has been a little bit. I'm not sure. I'm not privy to anyone that's using it like kind of at the cutting edge, but certainly the more we know about, the more data we can cram into a computer about a volcano's past behavior, then AI could be used to make, rough forecasts on how it might behave at a future time or in a present time. And so I have no doubt that's being used to some degree. Tricky with ones like Santorini, though, is they don't erupt very often. And when they do, they have these large events. And so we go sometimes decades, centuries or more of quiescence, of not much happening. And then we get a big event. And so you're kind of looking at a more limited data set punctuated by these few events versus something like Kilauea or Iceland, where we have decades or hundreds of years of eruptions happening quite frequently, which gives us a better, more rich data set.
So how do you know about volcanoes dating back thousands of years ago?
Yeah, so we use, if there's any historical records, that will be helpful. But of course, people thousands of years ago weren't, running outside after an eruption and like measuring the thickness of the deposits and stuff. So we look at the rocks, the rock record. So we can excavate and trench into the earth. We can measure how thick, we can see what it erupted. Did it erupt lava or ash? Lava is fairly innocuous. It's generally, it destroys real estate, but people oftentimes aren't killed by lava. Did it produce ash? Well, ash is a totally different beast. How much ash did it put down? How big are the particles? How widely distributed was that ash? What was the total volume that the volcano erupted? This is how we get estimates for places like Yellowstone, where we know Yellowstone's a quote unquote super volcano, is we've actually looked and seen how thick and widespread those ash deposits are. And then that gives you a volume, and that lets us know that those eruptions are truly like at a very large scale, like massive. They're very large.
Okay, so you brought us back to the U.S. I want to talk about some stuff in the U.S. We currently have one that's been in the news every day in Hawaii. What is going on with the Kilauea volcano, and how long has that been going on? Or what's going to happen here? Is this leading up to something big?
No, the Hawaiian volcanoes are just very different. They're a different magma type. So as we think about volcanoes, it's important to recognize that the composition of magma beneath each volcano varies. The magma underneath Santorini, for the most part, is thicker and stickier and goopier, and it traps gases. So as the gases are trying to escape, it's like molasses, and the gases can't escape very easily. So that gas pressure builds and builds and builds. It might go centuries, it might even go longer. Ultimately, it's leading towards an eruption, and a big eruption, but we've got a lot of time between eruptions. In contrast, in Hawaii, we have a very runny, a very fluid type of magma called basalt. And so the gases can escape easily, and we get much more frequent eruptions in Hawaii that aren't explosive and that don't cause much in the way of hazards. And so the Kilauea volcano in Hawaii has been a fascinating one because it's erupted between 1983 and 2018, it erupted every single day, like nonstop for 35 years. And then in 2018, it did something totally different, and it sent magma further down the slope, and it erupted in the middle of a neighborhood and had a truly historic, and it emptied the magma chamber at the summit and caused collapse there. And since that time, more recently, Kilauea's behavior has become a bit more routine, a bit more not necessarily predictable, but easy to forecast. It's erupting at the summit, which is good because there's a huge crater up there. So there's a lot of place for that lava to go. So it doesn't pose any sort of threat to infrastructure. And it's been erupting when the gas pressure reaches a certain level, and lava kind of gets shot out of these little vents, but it accumulates in that crater. And it's a nice tourist location. I was actually there a few weeks ago, and it was fantastic. And there were tourists just sitting there watching it and taking pictures, and very safe. And then after an eruption, it actually starts rebuilding pressure, and we can track that pressure with the ground deformation, looking at things called tilt meters to see how much the tilt of the volcano is changing. And when it reaches a certain level, the USGS usually says, hey, we're in this window, a couple days or so, of an eruption being likely. And sure enough, that's what we've been seeing. So it's been behaving pretty routinely, but Hawaii is a nice volcano. It as far as I know, at least in modern times, no one's died for the most part from Hawaiian eruptions. They're oftentimes a desired destination for people to go. But a volcano like Santorini is at the opposite end of the spectrum. It's naughty. It's much more explosive.
Okay, so what about like Mount St. Helens and Mount Rainier? Are they naughty or nice?
They're a little bit of both. I like to call those the bipolar volcanoes because they have the ability to do both. They can have large explosive eruptions like Mount St. Helens had in 1980. 50 some odd people died. It was a historic eruption. People who were around at that time remember all about it. It produced ash. But then people don't maybe not be aware that from 2004 to 2008, it erupted again. But it didn't produce ash and no one died.
I didn't know that. Yeah.
Yeah. It actually just oozed out this thick, pasty lava in the crater at the summit. I actually climbed it in 2006 and we looked down and we were watching this thick, pasty lava. You couldn't see it glow because it was during the day, but that's what we were looking at. And it did that for 4 years. And it wasn't much in the news because it was a kind of boring, simple event. So that's it, kind of its nice behavior. So those types of volcanoes like Mount Rainier and St. Helens oscillate a bit from explosive eruptions of ash and then these more innocuous eruptions of just thick, pasty lava that just oozes up somewhere near the crater summit.
What constitutes an active volcano?
Yeah, the definition of an active volcano is kind of nebulous. I think the USGS and other geologic agencies have often said that it's a volcano that's erupted in the last 10,000 years or shows signs of continual eruptive behavior or, behavior that could culminate in an eruption. So it's a different criteria, but it's arbitrary, right? I mean, Yellowstone hasn't had a big eruption in 640,000 years. And yet everyone would say Yellowstone's active because you go there and you see water shooting out of the ground and I see the steam and I can smell the sulfur. And yet it hasn't done anything for over 500,000 years for the most part.
But the way that you've explained it makes it sound like that's inactive may not be a good thing. It may mean like it's overdue, right?
Right. So that's the problem is, when we start labeling volcanoes, it can create a false sense of security, right? Because if we deem a volcano dormant or inactive, and then let civilization to kind of creep up its flanks and get developed and people live closer to it, then it could be due for another eruption. And these more explosive volcanoes like Yellowstone or Santorini or even Rainier or St. Helens, we know they sometimes go centuries of just no activity at all, but that clock is still ticking inside the volcano. The pressure's building, and at some point we have an eruption. Thankfully, we have the tools now. Volcanoes very rarely catch us off guard. We see the signs, we see the earthquakes, we see the ground deformation, and so we can chart and monitor its progress and activity, and it will give us warning signs that it's possibly going to erupt. And so the old days of us just being caught off guard by there we are out in the garden, and then the next minute, like Pompeii, right? And Vesuvius would be a good example of that. Those days are gone because we have better techniques now, and we can kind of really look at the data for these volcanoes and monitor them closely.
Are there any volcanoes around the world that worry you?
There's volcanoes that we probably need to take more seriously than we do. And then there's volcanoes that we overhype, like Yellowstone. Like Yellowstone, we've done studies on the magma in Yellowstone, and it's mostly crystallized. There's really good evidence that shows that the magma in Yellowstone right now is not even eruptible magma. It's like mostly a crystalline mush. And it's going to take a long time, like well beyond our lifetimes, for that to change into something that could erupt. And then there's volcanoes. A lot of them are in underdeveloped countries or places where they maybe don't have the infrastructure and the resources to really monitor their volcanoes. And they've let, civilization has crept further up their flanks. The Campi Flegrei volcano in Italy, which is a large system, you've got a whole urban setting just kind of sprawled across that thing in Italy. Yeah, that one is something to be concerned about. But thankfully, these are the volcanoes that don't erupt that often, right? So while we want to monitor them and watch them closely, your human lifetime of 100 years coinciding with one of these huge Santorini type eruptions is really small. So your 100 years or so on this planet also coinciding with something on that scale is very low. So like I tell my students all the time, like death by Yellowstone is way down at the bottom of the list. Like there's there's 100 more things more likely to take you out than...
I don't know. You could get charged at by a bison there, right?
Well, yeah, exactly. Like driving your car is way more dangerous. Like, you know, we probably more likely to get hit by a meteorite or crazy weather that you study or something, right?
Yeah, for sure. Okay. So in the fun of all of this folklore, do you think that Santorini is the lost city of Atlantis?
Oh boy, I'm not a history buff per se, so I don't know that much about it. Yeah, I don't think so, but I don't have enough knowledge on the subject to really say one way or another. I look at the rocks, I look at the volcanoes. When you add people to the equation, it gets really complicated really fast, and that's when I kind of check out. Fascinating, but yeah, not my forte or my skill set.
Shawn, you're an amazing teacher. I've learned so much from you in just a short period of time, and you have a YouTube channel where people can learn more, right?
Yeah, so I have a YouTube channel, just my name, Shawn Willsey, Geology Explained. I'm really passionate about people just learning, they're interested. And so we cover some volcanoes that we've talked about here, like Kilauea in Iceland. And I just post educational, informational videos. It could be a field video where I go outside and look at a road cut on a trip somewhere. Could be classroom sessions, just different ways for people to learn about this amazing planet of ours. I'm very passionate about that.
Awesome. Shawn, is there anything else you want to add?
I think the general lesson is don't rush to conclusions. Let's let the situation evolve. Let's look at the data. While there certainly needs to be concern for these earthquakes, you know, in the Aegean Sea and precautions taken, you know, jumping from a cluster of earthquakes of moderate magnitude to cataclysmic Santorini level explosions that are going to wipe out everyone. That's a bit much, right? Like we need to take it with a grain of salt. Let scientists do their work. Let the science kind of bear itself out. Take a deep breath. And remember that the worst case situations, these like high impact but low probability events, they're probably not going to happen, right? You know, how often do you get a Category 5 hurricane? Not that often. Tropical storms, every year, right? Dozens. How often do you get an F5 tornado? Not that often, right? F0, very common, right? So it's the same with these volcanic eruptions or these earthquakes. The big event, the headline event is the least likely. Doesn't mean we shouldn't be prepared for it or, you know, making precautions, but we shouldn't be so alarmist when we look at these things.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes published every Tuesday morning. Also, Off the Radar is on Instagram. Make sure you give us a follow so you can see snippets of the show as well as other great weather content. Thank you to Shawn Willsey from the College of Southern Idaho for joining me today. Check out his YouTube channel, Geology Explained, if you want to learn more about volcanoes. Thank you to the National Weather Desk and Sinclair Broadcast Group for their ongoing support of the podcast, as well as my associate producer, Brian Petras, for his help writing today's episode. I'm meteorologist Emily Gracie. Make it a great day.